This is the routine that builds the grade data list. This data will be accessed using the offsets list. NG is set to 1 less than the number of bits because the loop starts from 0. It will loop the bit count times. K is set to the offset for the first item's profit. L is set to the offset of the first item's part needs. NS control register is set to the number of parts. RCOL and MUL-L actions need this value. It's the part count. 4I starts a loop that goes around for each bit. R is set to the bit's item number. F is set to the bit's factor. An item with a maximum quantity of 7 would have a bit for 1, 2, and 4. Those would be the factors. This item would have 3 bits. The factors for the bits would be 1, 2, and 4. P is set to the item's price. The required values for an item are in a column. RCOL, which is row to column, will change the column to a row. This allows the MUL-L action to multiply each requirement by the bits factor to make a grade data list. The first bits requirement list is at offset 1020. This offset is changed by 20 for each bit in the loop. The first bit's price is placed at offset 2020. This offset is changed by 20 for each bit in the loop. When the bit is removed from the solution, the offset is increased by 1000 and it has a negative value. K and L are increased by 20 for each bit. The next I will repeat the loop for each bit. The requirement data will be copied at 1000 offset and it will be negative. Requirement is replaced. There is a list of 18 values for each bit. All the values are 0 except the value for that bit is 1. A second list of 18 values for each bit has all zeros except the value for that bit is -1. First, all the values are set to 0. 400 at grade data plus 4000 and 400 at grade data plus 5000. The 1 value is placed at 4020. The first -1 value is placed at 5020. 21 is added to these offsets, so the value will be for the next list, that's plus 20, and the next bit plus 1. When a bit is added into the solution, its 4000 offset is used. When taken out, the 5000 offset is used. The first box on the right has a list of parts needed for bit 1 at offset 20, also bit 2 at offset 40. When the bit is added to the solution, the list of parts needed is subtracted from the available list. The second box on the right has a list of parts needed for bit 1 at offset 1020, also bit 2 at offset 1040. When the bit is taken from the solution, the list of parts needed is added back to the available list. The third box on the right has the price for bit 1 at offset 2020, also bit 2 at offset 2040. When the bit is added to the solution, this value is added to the solution's value. The fourth box on the right has the minus price for bit 1 at offset 3020, also bit 2 at offset 3040. When the bit is taken from the solution, this value is taken from the solution's value. These are offsets in the gray data list. Here at offset 20, we see the requirements for the first bit is 4 and 3. And when it comes into the solution, it subtracts them from the available quantities. And down here, starting at offset 1000, and at 1020, it's putting back the requirements of 4 and 1, adding them back to or 4 and 3, adding them back to what's available. And here for the second bit, it adds back 8 and 6. It's exactly twice the 4 and 3 because this is factor 1 and this is factor 2 for the same item. Then down below there is where the profit is. At offset 2020, it adds in 5 when that bit becomes in the solution. Adds 10 when it's in the solution 2 times because that's what it's at 40. The opposite happens down here when it's taken out of the solution. The profit minus 5, and when it was in twice, minus 10.